Mode.
Good evening, everybody. Thank you for attending. Here we go, that looks better. Thanks for attending tonight, vBrownbag US Wednesday evening. Today we are going to continue with our AWS Solutions Architect Associate Certification training series, and tonight we're going to talk domain 4 with the troubleshooting domain. We've got Zeid from AHEAD. Is it just AHEAD, Zach, or is it AHEAD something?
It's just AHEAD.
Okay, from AHEAD. And a couple of quick housekeeping notes, and then we'll get this thing lit up. Get in on the conversation. I am monitoring the Twitters at vBrownbag, hashtag vBrownbag. Not LATAM or EMEA. You know what those other webinars are. Tonight, like I said, we've got Zeid on the hook. He has got a GitHub repository, github.com/Zeid. I, of course, am Chris Mistwire, and away we go. Oh, one quick request. Tonight we are going to have our Q&A at the end. So I will be monitoring the questions, but we're going to save them all for the end. Thank you for understanding. All right, Zach, here we go. You are now the presenter.
All right, sounds good. See my screen?
I can see your screen now, sir. You're good to go.
Excellent. All right. As you know, my name is Zeid. I'm going to be talking to you guys about domain 4.
I mispronounced your name.
Oh, no, that's fine. But I'm going to be talking about domain 4 troubleshooting for the AWS Solutions Architect Associate Certification. So, hold on. There we go. Who am I? I'm Zach. I have 15 years experience in IT support. 8 of that has been in IT support, 6 in operations infrastructure, 3 as a DevOps practitioner at FireEye, 1 as a partridge in a pear tree, and I'm currently the cloud services engineer at AHEAD.
Wait a minute. You're also the 12 Days of Christmas? That's awesome. Okay.
I also am the 12 Days of Christmas.
Hot damn.
I'm a tinker of AWS. You could say I have 4 of the 5 AWS certifications, and I'm currently studying for the DevOps Pro, which is tomorrow, so wish me luck on that one.
Good luck, man.
Thanks. So if you've been following the vBrownbag series, you'll know that there's been 4 domains, and the most recent one was domain 2 with Brian Crowson. And again, to reiterate, this is domain 4, which is troubleshooting. So the troubleshooting is the smallest objective of the exam. It's worth 10%, so there may only be a few questions on the test overall, but it will allow you to pick up those questions fairly quickly. The troubleshooting domain itself allows you to get more involved with some of the intricacies with the AWS services, and this domain will touch on all the services covered by other domains. So if you see me talking about stuff that's been covered in other domains, well, you're just learning it even more. So again, this is general troubleshooting and information and questions from the blueprint itself. And some of the success criteria I found in this domain is having a solid grasp of the core AWS services, such as your VPC networking, your EC2, EBS, CloudWatch, etc. A basic understanding of your networking fundamentals is key here. So know your OSI model. This is essential to troubleshooting most network and application connectivity issues. And this is very similar to the shared responsibility model, where you're really looking at the host layer instead of the media layer of the OSI model. And having basic troubleshooting skills is essential. So TCP dump, netstat, things of that nature. So some of the topics covered here is going to be networking, compute, storage, and monitoring. AWS services are fairly expansive, so I've picked these to be some of the concepts I'll be focusing on. So we're going to get started with AWS networking here. So if you've gone through the other domains, you should know a bit about the different services, so I'll try not to get too in the weeds. For the exam, you should have an understanding of the following networking concepts as it applies to AWS networking and VPC design. I mean, this is a solutions architect exam after all. So route tables. Route tables, they are a logical grouping of route rules. They're designed to route network traffic to various destinations such as your VPC gateway or an elastic network interface of an instance. By default, all subnets are associated with a single default route table. The route tables allow inter-subnet traffic through a local route. This route rule is immutable, so if you wish to restrict traffic, AWS provides network security features in the form of security groups and network ACLs, which we'll cover later. By default, the route table will direct all outbound traffic through the VPC Internet Gateway if one was made on VPC creation. And when a VPC is created, all the subnets within that VPC are associated with the default route table unless otherwise specified. So network access control list, this is a layer of the VPC that provides some security controls for traffic to and from the subnets. The nature of the network ACLs is that they're stateless, which means you must explicitly allow both an outbound and an inbound rule if you want to allow that traffic. Network ACL rules are evaluated in order, so if you have a deny rule for a subnet, but then you have an allow rule for an IP within that subnet, the traffic will be denied for that IP. And each NACL table has an explicit deny rule. So if none of the traffic to the subnets meets those rules within the table, it'll automatically be denied. Subnets associated with the network ACL table, subnets must be associated with the network ACL table and by default are associated with the one that's created by the VPC. As a note, you can have up to 20 inbound and 20 outbound rules, but you're going to see some network performance degradation when you start getting that many rules in a single table. And it's always a good practice to use a security model that involves least access design when it comes to designing your VPC. So security control group, security groups. As network ACLs act as a firewall for your VPC network, security groups act as a firewall for your instances. Security groups are stateful, so you don't need an explicit outbound rule added to the security group. Security groups only filter based on destination port. For example, you can't specify an allow rule for specific traffic from a source port. You also can't add in a rule to a DNS name, so it's only setter blocks. AWS does allow security groups to nest, so security groups can have rules referenced by other security groups. For example, you can allow port 22 from security group B to security group A, and instances associated with security group A will allow that traffic. I found that nesting security groups is a good way to get around some of the AWS security group and rule limits, but I found that it's sort of burdensome to troubleshoot that when you're trying to figure out why connectivity from one VPC to another isn't working. So keep that in mind when you are using them. EC2 instances can be associated with as little as 0 security groups or as many as 5 security groups. And AWS recognizes, that there are these limitations and they continue to grow it. So I think when I first started messing around with AWS, you could only have 20 security groups, and now it's 50, for example. So we have your VPC gateways. So I talked about network ACLs, which involve traffic to and from subnets, and I've talked about security groups that involve traffic to and from instances. Gateways involve traffic to and from VPCs, and AWS uses gateways to allow traffic from instances to communicate out to the internet. The default gateway, pun intended, is the internet gateway. This is a component of the VPC that's designed to be scalable and redundant, and it is the default gateway that is referenced by the route table created by the VPC. There can only be one internet gateway per VPC, and that internet gateway needs to be attached to the VPC to allow it to work. You have your NAT gateway. This is a relatively new feature that this allows non-public facing instances to communicate out to the internet. It's burstable to 10 gigabits per second, but it needs to be associated with a public subnet, and it can only be associated with a single subnet at any given time. The function of the NAT gateway is to allow instances to communicate outbound, so you can't use it with some of the following networking features. You can't use it to route traffic to a VPC endpoint. You can't use it to route traffic over a VPN connection. You can't use it to route traffic through your direct connect connection, and you can't use it to route your traffic over a VPC peer. And then you have your VPN gateway. And the VPN gateway is a component of the VPN connection that is needed to establish a VPN connection. It is one of two components necessary to create a VPN connection. So you need a customer gateway that references your endpoint to create an AWS VPN connection. You can't use it to reference another AWS VPN connection, but you can use it, for example, if you had an EC2 instance in a different region, you can establish an IPsec tunnel that way. One of the issues that I've typically found is with VPN connections, if you're not advertising the routes to your on-prem network, then it's not going to be able to communicate, and a lot of people forget that it needs those routes advertised. And then you have your VPC peering. And VPC peering gives you the ability to route traffic between private CIDR blocks. So this is your 192.168 routing traffic to your 172.16 VPCs. This is really good to use as a hub-spoke model. So like your management VPC can be used to monitor your dev and your QA and your production VPCs. And they all can route traffic through your management VPC to give you that insight into your environment. You can also specify specific subnets to peer, but again, this will leverage route tables. It can't be used in a transitive manner. So as you can see in the diagram here, that you have VPC A as the hub and B and C as the spoke. VPC B and VPC C cannot talk to each other through VPC A. You can't also leverage it as an outbound gateway. So we have VPC B here trying to communicate to the corporate network through VPC A. It's not going to work. There's a really good video, I think it's called A Billion, like a day in the life of a billion packets, and that really goes in depth about how AWS does their networking on the back end, and I highly recommend watching it as a part of this certification overall. As another note, you can't peer between regions, so if you're trying that and you fail, you check to make sure that they're not in different regions. All right.
I'm sorry, could you say that again? What was that video? A billion packets?
I have a resources page here, but yeah, I think it's a day in the life of a billion packets.
Awesome. Okay, cool. Thanks.
Yeah, something like that. So we're going to go into sort of not really a demo, more of a scenario to walk you through things you're going to be looking for. And the scenario here is you're an administrator who can't connect to an instance and it keeps timing out. So what should you be checking for? And the hint here is, remember your OSI model. So let's see if this works. So, all right, cool. So some of the things we're going to check is, well, first, we're going to check to make sure that is the VPC running. It's running. The status checks are good. So yeah, it's running. Does it have a public IP? It does have a public IP, so that's good. That means if it has a public IP or an EIP, at the very least, it's publicly accessible. Then we want to check our security group rules, and we want to see that it does allow the traffic that I'm trying to connect to. It does allow traffic to that port. So we checked that, and now we're like, okay, so it's running. You have the traffic open on a security group. Let's go and check the VPC. And we want to go and we want to look at the network ACLs. And looking at the network ACLs, it has two of the subnets associated with it, so we know that any network ACL rule is going to be applied to those subnets. And now we look at the rules and we see that it has allow all and it has allow all outbound. So we've checked that and we're like, okay, well, what's missing? What are we missing here? We go and we look at route tables. And now you can see here that I put it into, and let me know if I'm going too fast so you guys can keep up here. We put it into subnet 11 DCAD75. So we go and we look at this route table, and we see that it's associated with this route table. We look at the routes and we see that it doesn't have a route outbound. So we're going to go in here and we're going to add another route for the default route. Now I really don't recommend doing this for your private subnet, and I'll go into a little bit about the difference between a private and a public subnet. So we go and we save it, and that was successful. And we go, we SSH into it, and hopefully that works. And bam, there we go. So go back to this guy. So we thought about the OSI model. We checked to see if the instance was running. We checked to see if it had a public IP. We checked to make sure that it had, an associated network ACL that allowed inbound and outbound traffic. And we checked to make sure that the associated security groups allowed traffic inbound to the port I was trying to connect on. So I didn't really cover this, but this is a key feature that you guys want to keep in mind when doing infrastructure design for your VPC, is what makes a subnet publicly routable. So a few things that make it a subnet a public subnet is there's a parameter when creating a subnet that allows instances deployed in that subnet to be auto-assigned public IPs. So when I deployed that instance, in that subnet, it had the IP address already automatically assigned to it. The VPC needs to contain a gateway that allows outbound traffic. So one thing you want to check for is, does it have a gateway attached to it? Like your NAT gateway, an internet gateway, or a virtual gateway. And another key thing that you need is to make sure that the subnet is associated with a route table that has a default route to any of those gateways. And so that's what makes the difference between a public subnet and a private subnet. And I have a Lambda function that goes off every night, and it makes sure that every instance within a private subnet, as defined by these characteristics, remains private, because it only takes a couple of clicks to change that. So we move on to AWS Compute, and AWS provides compute in the form of EC2 instances, and there's a few different pricing types which you will need to know for the exam, but it's outside the scope of this domain. But there are two different flavors of compute which we will cover. You have your instance store backed instances. These are your directly attached stores. This is the compute type where the storage is a part of the physical disk of the host, and data on this instance does not persist in the event of an instance failure. So a key thing about these instances is that they cannot be rebooted, they cannot be stopped, and they cannot be started except on their initial creation. They can only be terminated. And then you have your EBS-backed instances, which is your network attached storage. And this is the compute type that leverages EBS volumes for both its root and data volumes. And since it's network attached and a separate service itself, data on these EBS volumes do persist when the instance is stopped. The volumes can be snapshotted as a part of your backup or DR strategy, or you can use them to create a new instance from. A key note is when you are creating an EBS volume, they must be in the same region and AZ as your instance when you're attaching them. So we're going to talk a little bit about autoscaling. And this is more going to be focused around some of the gotchas about an autoscaling event. It's a service within EC2 that automatically scales instances in response to specific CloudWatch metrics or other triggers. So some of the things you want to look for when an autoscaling event doesn't happen is, well, you want to look at the activity history to see why it's not launching. And you can see here, I have successfully launched 2 instances, but this is where you would go to see why it didn't trigger. So some of the things you want to check for with autoscaling is you want to ensure that the CloudWatch metric alarms that you set up trigger an autoscaling action. This is something that's configurable in CloudWatch, and we're going to cover that a little bit later. You want to ensure that CloudWatch metrics match the autoscaling policy, and you're going to need to adjust your metrics as needed. So if you have your metric to trigger on 90%, but your CPU utilization it only goes up to 80, it's just not going to trigger. So you should adjust your baseline accordingly. One of the things that I've run into a few times when creating autoscaling groups is you want to make sure you don't hit an AWS service limit. There's been, like I said, a few times where I'm trying to spin up 10 or 20 instances and they all fail because I ran out of, I hit my limit. And that's going to be a manual ticket to AWS to increase your limit. If you're asking for like 100,000 instances, well, they're probably going to want to talk to you. Another thing you should check for is to make sure that your launch configuration isn't misconfigured. This is kind of rare, but I still run into it from time to time. And then you want to check IP exhaustion in the subnet. And this is especially important if you're doing autoscaling groups and ELBs in the same subnet. And we'll go into a little bit why that is with load balancers. And then you want to ensure that your max and current instances aren't equal. So when you look at this, your max instances, that's as far as your autoscaling group is going to scale out. So if your max and current instances are equal, then you're going to want to bump your max instance, and you really should have some type of notification when you hit your max instance to begin with, so you can go ahead and bump it up before you run into these limits. So we're going to talk about load balancing next, and that's again another service within EC2 that allows traffic to be load balanced over multiple instances. You have 2 types. You have your application load balancer, which was just released, I think, 2 weeks ago, 3 weeks ago now. Was at the AWS Summit in New York. And then you have your classic load balancer. I'm going to focus more on the classic load balancer because I feel like that's going to be more on the exam right now than the application load balancer. So some of the things you're going to want to check for when troubleshooting load balancing issues is, if your load balancer isn't, load balancing across the instances, you want to ensure that, if it's in a multi-AZ architecture, that the cross-zone load balancing is enabled. If it's in a single AZ architecture, you're going to want to check for session stickiness or some sort of, maybe the loading policy isn't working as properly. If your instances aren't coming up healthy, this can typically be a networking issue. So you really want to confirm that the subnets that are associated with the load balancer can communicate with the subnets that the instances are on, especially if they're separate subnets. A consideration here is that an ELB listener isn't a security group. It just tells the ELB what ports it needs to listen on, and the ELB will need its own security group that will allow traffic in. And then the instances will need to allow traffic coming from the ELB itself. And if the instances aren't checking into the ELB, you want to make sure that the subnet is properly associated with the ELB. And again, this is a lot of like networking considerations. Like, are the subnets, protected by a network ACL? Are my security groups too restrictive? Am I allowing the proper security groups through, right? So we're going to go into scenario 2 here, and this is really recovering a data from a failed instance. So here I'm going to attempt to show you what you would do to recover instance from data from a volume here. So give me a second. Let's see. So I think that's it. Yeah. No, wrong one. So we have this guy here, scenario 2. I'm going to SSH in that guy. Awkward. Oh, wrong one. Happens.
This is exactly what happens every time you have a live demo. You're a brave man, sir.
So you can see that I've somehow messed up my sudoers file. Hopefully everyone here knows Linux. So you never want to edit your sudoers file without vi sudo, like I did here. And I'm pulling this out of a real-life experience I did many, many years ago, and so yeah, that's awkward. So what we're going to do is we're going to stop this instance because we need to get back into that instance, but we can't do it without being able to sudo to escalate your privileges to a super user. So we're going to stop it, and yeah. I guess, yep, it's down. And we're going to take note of the EBS ID here, which is VOL 02E92980. And we're just going to click into it. And hopefully it will be stopped by now. We're going to go ahead and detach it. No. Maybe not, or maybe not. That's what I get for trying to do a live demo.
It's all good, dude. This is par for the course.
It'll work this time, I swear. Let's give it a shot. All right. There we go. Whew.
Shablam.
There we go. All right. So now it's detached, and we're gonna attach it to another instance. And in this case, we're gonna attach it to scenario 1, which is running. We're going to give it, some sort of dev SDC or whatever, some block name here, and it is now in use. And what we're going to do is we're going to go to let's see, are you good? Yeah. All right. We're going to go over to this guy, and you're going to see that we now have vol 02 E92980. That's attached to the block to the instance. We're going to go into that guy. We're going to do It's ls block. Yeah. We're going to see here that you have xvdc, which matches the block mapping for this device here. And what we're going to do now is we're going to do some sudo magic. I'm hoping everyone here knows Linux, so I'm making a huge assumption. So we're going to make a we're going to make a directory, and then we're going to mount that device to that mount point.
I think it's safe to say that if we don't have if we do have people here that are not comfortable with Linux, if they are going for their AWS certification, now would be an opportune time to get up to speed on that.
Yeah, maybe just a little bit. And I chose Linux over Windows for my profession just because I could get the operating system for free. So don't hate me.
It's all good.
All right. So now we've mounted it, and you can see that this is mounted. You have your 8 gig drive here, and then we're going to go mount data file etc. Then we're going to go into the sudoers file here, and we're going to see, oh, that's where I messed up, guys. Go and remove that line. And then you want to do unmount it. And this is just a good way to make sure that it's actually unmounted, because there's been a couple times where I didn't check and did an rm-rf. Oh. There we go. And we go and we do an ls on that data volume, and you can see nothing's there. So we can safely do it this time. So now that we've done that, we're going to go ahead and we're going to click back into this guy. We're going to go ahead and we are going to detach it. It should be a little quicker this time. So once that's detached, what we're going to do is we're going to go ahead and reattach it to the original instance that it was attached to. And so here's a thing here that's sort of a gotcha. Because this was the root device of this instance, this will not work here. You need to tell it explicitly to mount back to dev xvda. Otherwise, when you mount it and it try to start it, it's going to say can't find a root volume, which is never a good thing. So we're here and you see scenario 2, and now you see this guy is back and it's reattached. And we're going to go ahead and start it. And it's going to take a few minutes to initialize, but we'll revisit this at the end. I'll show you guys that it actually worked. I swear it did. Okay. All right, so once I'm going to let that start up, and then we'll revisit it. We're just going to move on to AWS Monitoring. And AWS provides a couple of different ways to gain visibility into your AWS environment. This is through both their CloudWatch and CloudTrail service. For this domain, we're going to be specifically focusing on CloudWatch and the CloudWatch Metrics feature, as that tightly integrates with a lot of the services we've already covered. So you have your CloudWatch events and your CloudWatch logs and your CloudWatch metrics. Your CloudWatch events is your log, is sort of like your log filtering feature within that service. You have your CloudWatch logs, which is your log aggregator, and then you have CloudWatch metrics, which is the service and feature that monitors operating specific resources, such as your CPU utilization, your network I/O, and your disk I/O. CloudWatch can also be used for custom metrics, like your application metrics, or maybe you want to monitor disk or memory utilization. But this typically requires either a third-party agent or a custom script And AWS provides one of these for your Linux instances, so that's really nice of them. Metrics are aggregated over a 5-minute period level of granularity, but if you have your EC2 instances with detailed monitoring enabled, this is a 1-minute interval. As a note, if you want detailed monitoring enabled, this has to be enabled per instance. So you can see here, I enabled CPU detailed monitoring for this instance, and you can see where it starts aggregating a lot more. So, and that's something, it's really good in conjunction with auto-scaling groups because it's more responsive. So instead of waiting for CloudWatch to aggregate a data point at 5-minute, it gets it at 1 minute, kicks off the auto-scaling event, and does its thing. So that's why you would want to use detailed monitoring. I sort of skipped over this when talking about compute, but AWS has their EC2 status checks, and this provides monitoring of your instances and their underlying hosts. So within each instance, there are 2 types of checks, and these checks are typically performed every 1 minute. You have your system status checks, which monitors the underlying physical hardware. So if this check fails, you can either stop the instance, it'll come up on a new host, or you can wait for AWS to resolve the issue. It's typically easier to just start and stop the instance. As a note, a reboot does not work. A reboot will bring it back up on the same host. It needs to be a start and stop. I don't know if you remember previously, this will not work for an instance store backed instance. So if that instance is hosed, then you're just going to have to terminate it. And then you have your so your system status checks. They check for the following. They check for the loss of power to the physical host, loss of connectivity to that host, or they also check for hardware software issues on the physical host. I don't know how many of you have been using AWS, but the CVE for the hypervisor back in 2014, that was a software issue, and if you remember, those required hard stops and hard starts. So, and then you have your instance status checks. This monitors your underlying hardware and software config of the EC2 instance. A failure of this check typically requires some sort of administrative intervention here. Though AWS has released a few ways to trigger actions with their CloudWatch events, which is super nice. A few things that would cause an instance status check to fail would be like a failed system status check, because that interrupts the functionality of a compute instance, an incorrect startup or network config, exhausted memory, corrupted file system, or incompatible kernel. And each of these checks are integrated into AWS's CloudWatch service, and then you can trigger specific actions based off alarms. So you can go back in here, and we're going to check to see if this guy, this guy is back up and running. So SSH, yeah. Is that the right one? Nope, wrong one. So we're going to go and we're going to SSH back into this guy real quick, just to prove to you guys I know this works. Yep. Yeah, and we're able to, escalate as super user. So here's some resources. As I talked about, a day in the life of a billion packets. I've included a link for your monitoring, and here's some white papers to help you, around best practices and architecting, well on AWS. Any questions?
Dadgummit, sorry about that. I lost my cursor and I couldn't find it. So yes, we've got a couple here. Let's see. Back during the security portion, somebody asked advertising routes up and down.
No, just no. You just want to advertise. For example, you have a 10.10.10.0/24 on your on-prem data center. You want to tell AWS that any traffic heading to that CIDR is going over the VPN connection.
Oh,
So you're
okay.
not advertising up down for your actual edge router IP.
Gotcha. Okay. And if you could send me a copy of your PPT, then we'll tag that with the information on the website. I want to get those links out to everybody because somebody asked for about a day in life of billing packets. The next question is, what does a service limit constitute? This was in regards to when you were talking about be careful not to hit your service limits. If you're spinning up another 20 VMs and you didn't know why they didn't come up, what is a service limit? How do you hit a service limit, and how do you know when you're getting up to a limit?
So it'd be easier to show you. This is a service limit. So you have your various instance limits, and you have your various EBS limits and your host limits, etc. These are just like your limits on the number of instances and the instance types that you can spin up. This is a way for AWS to do their whole capacity planning thing, and these are typically soft limits. There's only a few hardware limits out there, or like hard limits. So you want to use like Trusted Advisor, or you want to be able to programmatically get the limits here to know what your limits are at. So yeah, those are what the limits are, and keep in mind that your limits are per region too.
Gotcha. Okay, cool. The next one. So this one was during your first demo. The question was, why XVDA rather than SDA?
Because that's the way that AWS maps the root volume to the instances.
Okay. And another question was, can you set up notifications for when you hit max instances in an ASG, in an Autoscaling?
You know what? I'm not 100% sure on that one. I'm gonna have to look into it and get back to you. There are ways of setting up notifications to be notified of when you're hitting that. I'm just not sure if it's integrated into auto-scaling groups in general.
Gotcha. Okay, cool. All right. So let's see, what else? That was it for the local questions. There's some chuckle nuts named Brian Krausen who's asking questions somewhere. I'm just going to ignore those questions. He's
sounds good to me.
He doesn't get any questions answered.
He has enough to begin with.
For everybody else, Brian and Zach work together, so we're not being mean to anybody who doesn't deserve it, allegedly. So that is it. We are good for questions now. Zach, thanks very much for your time this evening. That was excellent. We appreciate your time.
Oh no, thank you very much for having me on.
Yeah, cool. Okay, so I'm going to go ahead and stop the recording now.